Hello, pre-calc classes. This is Mr. McAllen, and this is going to be a short video on how to plot or sketch exponential functions. The key word here is sketching. Remember, a sketch is just a graphical representation that is not accurate point by point, but we're going to use a handle to describe where the function has gone, and we're going to look at the curvature of the function, and we're going to look at the horizontal asymptote. So when we look at an exponential function, okay, every exponential function, for example, y equals 2 to the x or y equals 1/2 to the x, will go through the point 0, 1. That will be called our handle. And an exponential growth function, which is characterized by a base value greater than 1, the base is greater than 1, that will signify growth. And that could be thought of as, in your biology classes, you would have known this to be, when cells divide after so much time, they double in size. And that would be a growth function of base 2. And in chemistry class, when our base is between 0 and 1, as in this case, that would be like a half-life problem. So a growth function, exponential growth, would appear to look as such, with a horizontal asymptote at y equals 0. And it would have to show, growth as time goes on. As time increases in the x direction, you would see the function increasing. And a decay function, like a 1/2 decay function, would appear as exponential decay heading towards that asymptote. So here are the three things that I'm looking for that when you make these sketches that you have correct. The first thing is where the handle moves to, its new coordinate. The second thing would be the equation for the horizontal asymptote. And the third thing is, did you get the curvature correct? So what I want to make sure that we do when we graph these functions, for example, if I ask you to graph a function like y equals 5 to the negative x plus 2, I would want to make sure that you recognize the flip and secondly that you recognize translations. So let's get into an example. So I have 4 examples here that I want to plot very quickly. And the first thing I recognize is the parent function is y equals 3 to the x. So I'm going to just graph a quick sketch of 3 to the x. Remember, it's only a sketch. It's a growth function. It has a point 0, 1. And I'm going to look at which way does this function move. And because there are no negative signs, there are no flips. And we have a translation to the left 1 unit, because on the inside of the function we see the expression x plus 1, which means that the function is moving left 1. If you set x plus 1 equal to 0, you'll see that x equals -1, and that would indicate we're going to move left by 1. So let's just draw that. What we'll do is we'll just move this point back 1 unit. We'll give it the new coordinates. Let me erase those coordinates. That would be -1, 1. And I'm going to just have, I still have the asymptote in the same location. And I would have the function growing through that point. And that would be a good enough representation of an exponential growth function for 3 to the x plus 1. On the next function, I will draw the function 2 to the x. So it goes through the origin again, 0, 1. We have our horizontal asymptote. I'll just do that in blue so you can see it better. And the 2 to the x would look like this. And now I'm going to identify, I have a few things going on. First thing is I have a flip over the y-axis. So I'm going to take care of my flip first. And the second thing I have is a translation to the left 1 unit. And the reason why I know that is I take negative x minus 1, I set it to 0, and when I solve I get x equals negative 1, and that indicates a leftward movement by 1. So I'm going to first take care of my flip, and in red I'll show like the curvature of the function. I'm going to use that little piece to help me with a flip over the, I don't want this drawing to get cluttered, so I'm going to just like focus on it's just a small segment of the graph moving around at centered at the home or at the the handle of the function. So I'm going to draw a flipped version of that, and I'll just draw that in green. So that would be the flipped version, and then that's going to move to the left by 1 unit. So I'm going to move that over to the left, and I'm going to then draw that curvature. But now I'm going to add the whole curve in, and I'll do that all in gray so you could see it better. So that would be the whole function, and I would just want to relabel that point to be negative 1 comma 1, and that would be a good enough sketch showing 2 to the negative x minus 1. The next one, number 3, we have the function 5 to the x, so we'll start that out in black. And when you try drawing that, it's again going to be exponential growth going through 0, 1 with a horizontal asymptote at y equals 0. And when you analyze this function, you've got to first look and notice that you have a flip over the x-axis, and that's because of that negative sign. And the second thing is you have an upward translation. So the first thing you want to take care of is you want to take care of your flip over the x-axis. So that would put that point there at 0, negative 1. And you'd want to draw your flipped curvature. And then you would want to also move everything up by 1 unit. So then I'm going to move this curvature up by 1 unit, or curved section up by 1 unit. And then I'm going to put the asymptote, the new asymptote to the function. So everything I'm going to draw right now will be in green, which will be the new function because I have the flip taken care of. I have the point translated and the curvature correct. So I'm just going to sketch in what that new function should look like. And this function would be y equals negative 5 to the x plus 1. Last function, we have 2 translations and 1 flip. I'm going to start off again with drawing a growth function because it's 4 to the x. Goes through 0, 1. Remember, I'm only concerned with the handle 0, 1. I'm not worried about every single point on the graph. And I'm going to have the asymptote at 0. And now when I identify what type of flips I have, I first see that because of that negative in front of the x inside the function, I have a y-axis flip. And I have 2 translations. I'm going down 3, and I'm going to the left 2. So I'm going to take this point and I'm going to flip it over the y-axis. So I'm going to show that in red. I'll just show the flip with that little curved section. That's getting flipped, and now that graph is going to move down 3. So just count 3 points down and left 2, and I'll have that curvature there. And now with respect to that, you know that you have your new asymptote. And then you can draw in your curvature. And oh, we have to relabel the point, so we want to just make sure we relabel that to be That's -2 to the left and it's 2 down. So our point has moved from 0, 1 to 2, 2, and now I can draw my final function, which, remember, since it's a sketch, I'm just worried about making the right type of curvature and showing how the function behaves with the asymptote, and always make sure you're right next to the function what the new function equation is, 4 to the 2 minus x minus 3. I hope that, again, this has demonstrated for you how to draw a transformational sketch of an exponential function. Remember, the key ingredients to this are, you first have to identify the base, so you know if it's growth or decay to begin with. You have to identify your flips, your movements, and then when you do your flips or your movements, just work with a little tiny piece of the function that's going through the handle, and then you follow that little piece around the graph, and when you finally get it to the right location, you can draw your sketch in. Okay, anyway, I hope this helped, and I look forward to hearing your comments in the future. Please, if you like this video, like it or subscribe to the channel. Have a good day.